Doc Lorson, the science guy. Doc.
And a bowling pin.
And on that day, Sir Isaac Newton thought long and hard about what he had observed. He concluded that the massive attractive force exerted by the Earth upon all other objects must be constant. And apparently he got a text message. After much more experimentation, he discovered that this constant was always 9.8 meters per second squared, or 32 feet per second squared. And he thought, and he thought, and he scratched. And he decided he would call it gravity.
Okay, this needs to be...
Newton then decided to do further experimentation to find the actual value of his constant, g. However, it was not Newton, but rather Cavendish, who found the constant g to be 6 times 10 to the negative 11th power. The constant g does appear in Newton's law of universal gravitation and also in his law of relativity. Now, the equation is as follows. The inverse squared proportion is the constant gravity times the mass of the first object times the mass of the second object divided by the square of the distance between them.
What we can conclude from this is this equation. The force of gravity equals the constant times the mass of one object times the mass of the other object divided by distance squared. Now what this means, ladies, is everybody is attracted to me, and the closer you are, the more irresistible I am.
Well, it kind of sounds like yelling.
Feel free to ignore what he said, minus the equation part.
To reiterate, with a visual this time, we will go over this equation. The force of gravity is equal to the constant that Cavendish came up with times the mass of one object times the mass of another object divided by the radius or distance between them squared. For example, we will use the Earth and a person on the Earth. Now imagine that's you standing there. You have two masses of objects and a distance between them. Then you also have your constant ready to go. So you will list your variables to start. Mass of 1, mass of 2, the distance. Then you put them in the following equation, and you will get 1,960.4 newtons. But wait, significant digits, 2,000 newtons.
Ha! I'll bet you thought that was a transition, didn't you? But actually, it was a demonstration of the property of gravity that all things under the same condition will fall at the same rate. Let's have a look at the replay. Boom.
Catapult!
Oh, you've caught me practicing, but I'm about to show you can do it at home, too. Kind of.
Alright, so we're going to describe the physics behind a speaker, because everybody has them, but not really everyone knows exactly how they work. And we thought, what better way to do this than to actually build your own speaker? So Nathan was right, or Corey, or whoever, but you can do this at home.
Alright, you're going to need a cylindrical magnet that is fairly powerful. Some wire. I pulled mine out of some old Christmas lights that didn't work. A styrofoam plate. Some tape. A hot glue gun. A piece of cardboard that is bigger than your styrofoam plate, or at least as big. 2 index cards. And a regular old sheet of paper. You're going to take that paper and cut 2 identical strips that are wider than your magnet is tall, but you're going to make one of them just slightly shorter. And then you're going to wrap that shorter one tightly around your magnet, then securing it with a small piece of tape. You're then going to do the exact same thing with the longer piece of paper around all of that, making sure that it's tight, and securing that with a piece of tape also. then you're going to take your magnet out of that and put a dot in the center of your styrofoam plate and then glue around that, where you're going to put the paper cylinder back on and then put your magnet back in that and then start wrapping your wire around that. This part is very important, but it takes a long time and I messed up several times, so we're just going to go ahead and skip straight to the end where I secure it with a piece of tape, because you definitely don't want your coil coming loose. And you should have two ends, one that you started with and one that you ended with. And after you take your magnet back out, it should look a little something like this up close. You're then going to start taking out that center wrap of paper with some needle nose pliers. It doesn't really matter if it rips, because it just needs to be wide enough that the magnet can easily slip in and slip out. You're then going to fold your index cards into W shapes as the suspension for this whole thing, and you're going to glue your magnet into the center of your cardboard sheet, where you are then going to glue your whole contraption and suspension to that, making sure that it's right in the center so that the magnet slides in and out of the paper cylinder. Now, unfortunately, the wire that we used isn't really meant for a speaker, so it's a fairly low gauge and takes a lot of power to get running through it to make the speaker actually work. But that works out because I just hook it up to the surround sound system in our basement, where the wires are already exposed there, and so we could just unplug all the other speakers and then connect the wires to the wires that were out on our speaker. And so I'll just click play here, and because the microphone has to be like right up next to something for you to be able to hear it, I'll just put it there. So here it is.
There you have it.
Alright, now that you've built your speaker, you're probably wondering just how does it make that sound out of a styrofoam plate? And we don't really have any fancy diagrams like those gravity people had, but wait, we do? Oh cool, so we have a diagram for you.
Okay, so basically all modern day speakers have the same structure as the speaker invented by Alexander Graham Bell, where they all have a voice coil, which is just a tight but hollow coil of wire like ours wrapped around our paper cylinder, vibrates up and down on a magnet, which is usually fairly strong like ours was, because of alternating currents sent through the signal inputs, which is just the two ends of the voice coil. These vibrations are then amplified by a diaphragm, such as ours was the styrofoam plate, and that vibrates up and down on a frame that keeps it in place. The actual sound is produced because when you run an electrical current through a coil of wire, it creates a moving electrical field. And a moving electrical field then becomes a magnetic field with a certain polarity depending on whichever direction the current is flowing through the wire. Because the magnet also has a polarity, it will either repel or attract the voice coil depending on whatever polarity the voice coil is at the time. And because Tesla was a genius inventing alternating current, it makes it possible to very rapidly change the polarity of the voice coil. Doing this causes it to vibrate up and down on the magnet extremely quickly. These vibrations are then amplified by the diaphragm, causing very rapid alterations in air pressure that our ear depicts as sound.
Now that you've built your awesome speaker and you know how it works, you can go and feel smart in front of your friends like this.
Wow, those are some awesome speakers you have.
Oh, you want to see them?
Absolutely.
Yeah, that's it right there, that thing.
Holy crap.
Yeah.
How much did that cost you?
Under $1. I actually had all the parts right in my own home. You want to know how it works?
Yeah.
Well, you can see in here that there's a coil of wire and a magnet.
Oh yeah,
And
yeah.
when you plug it into your head unit up there, it just alternates the current and makes it vibrate up and down. And it's just awesome. It makes sound because,
I mean,
yeah.
I can hardly hear. It's so awesome, but Man, you must be smart. I'm really impressed.
Thank you. Yeah, it's always great to know that.
Yeah, I think I'm gonna get one for my ride.
Go for it.
Got one of these awesome speakers for my ride. I just can't figure out where it goes.
Hello again. See, I told you could do it. All you artsy craftsy people with your tape and paper plates and such. Yeah, goodbye.
Better sound quality brought to you in part by Rock Band.
Rock band.